If A vector and B vectors are constant vectors, R vector and P vector are generalized position and conjugate momentum respectively, then for the transformation Q is equal to A vector dot P vector and P is equal to B vector dot R vector to be canonical, the value of A vector dot B vector is. So in the question they have given a transformation Q is equal to A vector dot P vector and P is equal to B vector dot R vector. For Q1 P to be canonical, what is the value of A dot B? That is the question. So the condition for canonical is Q comma P is equal to 1. So they have given the value of Q and P. So A vector dot P vector comma B vector dot R vector, that is equal to 1. So this can be written dot product AX PX plus AY PY AZ PZ comma BX X plus BY Y plus BZ Z, and the Poisson bracket is equal to 1. Now take these two terms. This can be written as AX BX PX dot X plus, similarly take the Y term here and here. So AY and BY is a constant into PY dot Y plus AZ BZ PZ dot Z, that is equal to 1. So for remaining combination it will be 0. Now this is AX BX, this is going to be minus 1 plus AY BY minus 1 plus AZ BZ into minus 1. This is equal to 1. So we can take the minus common outside and bring it to the right hand side. So we will be getting AX BX plus AY BY plus AZ BZ is equal to minus 1. This is nothing but A vector dot B vector. A vector dot B vector is equal to minus 1. So answer is minus 1. A uniform block of mass m slides on a smooth horizontal bar. Another mass m is connected to it by an inextensible string of length L of negligible mass and is constrained to oscillate in a xy plane only. Neglect the size of the masses. The number of degree of freedom of the system is 2. The generalized coordinates are chosen as x and theta, as shown in the figure. If p of x and p of theta are the generalized momenta corresponding to x and theta respectively, then the correct options is R. So in this question, they have taken a block of mass m and it slides along this horizontal surface. Okay, it is at a position of x from the origin of the axis and it is connected to another mass of m, small m bob is connected to it through an inextensible string of length L. Okay, and they have given p of x and p of theta are the generalized momentum of x and theta. And also they have given the degree of freedom of this system is 2. They have given 4 options and among these 4 options they have asked us to find which option is the correct one. Okay, for solving this problem we have to find p of x and p of theta. First we will see what is the position of the block and mass. So the mass is at a distance of x from the origin. So here we will consider this distance as x1. Okay, and y position is 0, and in case of Bob the position of y is y2 and this x2 and y position is this one, right, y2. So at time t the position of block is x1 comma 0. and the position of Bob is x2 comma y2. Now we have to find what is the value of y2 and x2. First we will write x2 is equal to, x2 can be written as this distance plus this distance, right? This is x1 and this distance, if this angle is theta, then this distance is L sine theta. So x2 is x1 plus L sine theta, and similarly y2 will be this distance, this dotted line distance. It will be L cos theta, and it will be minus L cos theta. For finding P of x and P of theta, we have to find the Lagrangian. So first Lagrangian is equal to T minus V. Here T is equal to half capital M mass of the block into x1 dot square plus half mass of the bob into x2 dot square plus y2 dot square. So we have to find the value of x1 dot, x2 dot and y2 dot. So x2 dot will be nothing but x1 dot plus L into theta dot into cos theta, right? And y2 dot is minus of L theta dot minus sine theta you will be getting, so it will become plus. Now substitute the value of x2 dot and y2 dot here. We will simplify this separately. x2 dot square plus y2 dot square is equal to x1 dot plus L theta dot cos theta the whole square plus L theta dot sin theta the whole square. By expanding it and simplifying it, we will be getting x1 dot square plus L square theta dot square plus 2 times of L x1 dot theta dot cos theta. Now substitute this 2 here in T. Okay, then we will be getting T is equal to half capital M x1 dot square plus half into small m x1 dot square plus L square theta dot square plus 2 times of L x1 dot theta dot cos theta, right? Now we have to find. V is nothing but minus m gl cos theta. Therefore L will become half capital M x1 dot square plus half small m x1 dot square plus L square theta dot square plus 2 times of L x1 dot theta dot cos theta minus of minus plus, it will be mgl cos theta, right? Now we have to find dou L by dou x1. So Lagrangian doesn't contain any x1 term, so it will be 0, and we have to find dou L by dou x1 dot. First term and this term contains a x1 dot, so it will be 2 times 1 by 2 capital M x1 dot plus 2 divided by 2 small m x1 dot plus 2 times of L theta dot cos theta into m. So by simplifying it, we can write x1 dot capital M plus small m plus m into, here you will be getting 1 by 2 also. So this 2 will get cancels of m into L theta dot cos theta. Next we have to find dou L by dou theta. This term contains and this term also contains. So you will be getting half m 2L x1 dot and theta dot minus sin theta plus mgl minus sin theta. Then we will be getting m L. As a common factor, you can take it from both the terms, and remaining will be x1 dot theta dot plus g into minus of sine theta. So that also common factor. Okay. So then we will be finding dou L by dou theta dot. Theta dot is present only in this term. So we will be getting, sorry, here and also here. So by simplifying it, we will be getting L square theta dot square into m, and here 2 theta dot, and this 2 half m will get cancels off, plus m L x1 dot cos theta. So 2 and 2 will get cancels off, remaining will be this. Now we have to find which among the 4 option is the correct one. Okay, now here dou L by dou x1 is equal to 0. This denotes that Px is a constant. That is, x is a cyclic coordinate. Right, so we will see which option is correct. Option C, P of x is a conserved one. Okay, and we will see the next one. And dou L by dou x1 dot is nothing but this is equal to P of x. Right, so P of x value is given by this form. So we will see whether this is present or not. Yes, this is present as an option A. Okay, now we will see the next one, P of theta. P of dou L by dou theta is not a 0. So P of theta is not conserved. Okay, so this option is incorrect. Now we will check whether this option is present or not. If you take this option, this is P of theta. Here in our answer we have got minus plus here, but in the answer it is given as a minus. Okay, so this option is also incorrect. So answer is option A and C. A hop of mass m and radius r rolls without slipping along a straight line on a horizontal surface as shown in the figure. A point mass m slides without friction along the inner surface of the hop, performing small oscillation about the mean position. The number of degree of freedom of the system is. In the question, they have asked us to find what is the degree of freedom of this system. Okay, here this mass is having a rolling motion, right? So this capital M mass is having a rolling motion. So in case of rolling motion, it has a translational motion in one dimension. So this corresponds to a 1 degree of freedom. Okay. And if you take this smaller mass is simply oscillating with small angle theta. Angle theta. So which includes the one more degree of freedom. Okay, so total degree of freedom is 2. Consider a spherical galaxy of total mass m and radius r having a uniform matter distribution. In this idealized situation, the orbital speed v of a star of mass m as a function of distance small r from the galactic center is best described by. So in the question, they have given a galaxy of total mass m and the radius of the galaxy is given as capital R. They have taken a star that is moving with a velocity v and at a distance of r from the galactic center. They have asked us to draw what is the graph between velocity and the distance r. Okay, when r is less than capital R and when r is greater than capital R. We have to find what is the velocity for these two conditions. Okay, the velocity of the star is given by g capital M divided by r, the whole root. Consider this as a galaxy, and this let O be the galactic center and the radius of the galaxy is capital R. We will first consider the first case when R is less than capital R. The star is inside the galaxy. Let this be the position of R of the star, and the mass of the star is given by small m. Only this much mass of the galaxy gets attract the star. Okay, so velocity is equal to g. M will be rho into volume of the galaxy that is only present inside this region. So 4 by 3 pi r cube divided by r, the whole root. This r and this r will get cancelled. So we can say velocity is proportional to r square, the root. So velocity is proportional to r. So velocity and the distance have a linear relationship. Now if you see option B, it says the velocity is constant inside the galaxy. So this is incorrect. And in option D, V and R doesn't have a linear relationship. So this is also incorrect. Now we have to see for the second case. That is R is greater than the radius of the galaxy. Now we consider it is moving at this position R. Here there is no change in the mass of the galaxy, because whatever distance r value you take, the mass of the galaxy is not going to vary. So simply the formula will be root of g capital M divided by r. So here velocity is proportional to 1 divided by root of r. So when r increases, the velocity is decreasing. Right? Now in option C, you can see that after a distance of capital R, the velocity is constant. So this option is incorrect. Only option A is correct. Two observers O and O prime observe two events P and Q. The observers have a constant relative speed of 0.5 c in the units where the speed of light is taken to as an unity. The observer O obtained the following coordinates. Event P, x is 5 and y is 3, z is equal to 5, t is equal to 3. Event Q, x is equal to 5, y is equal to 1, z is equal to 3, t is equal to 5. The length of the space-time interval between these two events as measured by O prime is L. The value of L is, in this question they have two observers O and O prime. They are observing two events P and Q. Okay, both the observers are moving with the relative speed of 0.5 c, and c is taken as a unity in this case. And the observer O measures the coordinates of the event P and Q, and that is found to be these two values. Okay, and their question they have asked us what is the length of space-time interval between these two events for the observer O prime. In the question they have given the coordinates of P and Q measured by the observer O, and they have asked us to find what is the length of space-time interval between the events measured by O prime. The space-time interval is defined as delta S is equal to delta x the whole square plus delta y the whole square plus delta z the whole square minus c into delta t square. Okay, the whole root. And this space-time interval is invariant quantity in relativity. Whether this quantity is measured by the observer O or O prime, it remains invariant. Even though their frame of reference is different, this value will be same. So if we calculate the space-time interval for O, that will be equal to the value calculated for O prime also. So we will calculate what is the value of delta S in case of O. So we will calculate for O. Delta S is 0 plus 2 square plus 2 square minus 1 square 2 square the whole root. By simplifying it, we will be getting simply 2. So the answer is 2. The time derivative of a differential function g, qi, t is added to a Lagrangian L such that L prime is equal to L qi dot t plus d by dt of g, where qi dot t are generalized coordinates, generalized velocities, time respectively. Let pi be the generalized momentum and h the Hamiltonian associated with L. If pi prime and h prime are associated with L prime, then the correct statements is R. Both L and L prime satisfy the Euler-Lagrangian equation of motion. Pi prime is equal to pi plus dou by dou q g qi, t. If pi is conserved, then pi prime is necessarily conserved. H prime is equal to h plus d by dt of g. In the question, they have a Lagrangian L. They have formed a new Lagrangian L prime by adding the d by dt of g with the old Lagrangian L. And they have said pi prime and h prime are associated with the L prime. They have asked us to check which among these 4 options are the correct one. Okay, first let us write the given new Lagrangian, that is L prime is equal to L qi comma qi dot comma t plus d by dt of g of qi comma t. Right? Then we will see what is the time derivative of the given function g qi comma t. That will be equal to summation over k, it goes from 1 to n, dou g divided by dou qk dot plus dou g by dou t. Okay, then we have studied that what is the Lagrangian equation is. That is d by dt of dou L divided by dou q dot minus dou L by dou qk is equal to 0. If this new Lagrangian L prime satisfies the Lagrangian equation, then we will be having d by dt of dou divided by dou qk dot into L plus d by dt of g, right, minus dou by dou qk into L plus d by dt of g. Let us consider this as 1 and this as 2 and this as a third equation. In classical mechanics, we have already studied gauge invariance of Lagrangian. So in that topic, we have studied if L is a Lagrangian, for a system of n degree of freedom, satisfying Lagrangian equation, then it can be shown that L prime is equal to L plus d by dt of a function f. This Lagrangian L prime also satisfies the Lagrange's equation. Here f is a arbitrary function and this function f is given by f is equal to f of q1, q2 up to qn comma t. Now this function, such a function f is called as gauge function for the Lagrangian. Now if you see in the given question, they have given L prime is equal to L plus d by dt of g. Right here g is the gauge function for the Lagrangian equation. Therefore we can say both L and L prime satisfies Lagrangian equation. Of motion. Now if you see the given option A, both L and L prime satisfies Euler-Lagrangian equation of the motion. This is a correct option. Next we will see which among the remaining three options is the correct one. Now we will substitute equation 1 in the new Lagrangian. Okay, then we will be getting, so the given Lagrangian is L prime is equal to L qi comma qi dot comma t plus d by dt of g qi comma t. We have obtained that first derivative of g will be qi comma t, that is equal to dou g by dou qi dot plus dg by dt. Right, now we will substitute it here and see what we will be getting. L prime is equal to L qi comma qi dot comma t plus dou g by dou qi dot plus d by dt of g. Okay, now we will find what is the value of pi prime, that is dou L prime divided by dou q dot. Okay, so this is the Lagrangian. We will find the first derivative with respect to partial derivative with respect to qi dot. So that will be equal to dou L divided by dou qi dot plus dou g divided by dou qi. Right, now if you see this is nothing but the generalized momentum of the Lagrangian L. So we can write it as pi plus dou g divided by dou q. That is the generalized momentum of the new Lagrangian L prime is given by this equation. Now if you see the option, This option is a correct one. This is what we obtain now. Next we will find what is the first derivative with respect to time of pi prime. That is d by dt of pi prime. So that will be d by dt of pi plus d by dt of dou g by dou qi. Right. If we consider pi is conserved, that is d by dt of pi is equal to 0. Then if we substitute it here, we will be getting d by dt of pi prime is equal to 0 plus d by dt of dou g by dou qi. This implies d by dt of pi prime is not equal to 0. That is, if pi is a conserved one, it is not necessary that pi prime must also be a conserved. Right now, if we see the option C is a incorrect one. That is, if pi is conserved, then pi prime is necessarily conserved. No, it is not necessarily be conserved. So this is an incorrect option. Next we will see whether the fourth option is a correct one or not. Okay. So we know that Hamiltonian H is given by H is equal to summation pi qi dot minus L. In a similar way, for the new Hamiltonian, H prime will be summation pi dot prime pi prime qi dot minus L prime. Right. Now we have found what is the value of pi prime here, and we will substitute it here, and also the value of L prime. So then substituting it, we will be getting H prime is equal to summation pi plus dou g divided by dou qi into qi dot minus L plus summation I d by dt of g qi comma t. So in the beginning itself we have found what is the first derivative of g with respect to time. We will substitute that here. We will get h prime as summation over pi qi dot plus dou g by dou qi dot minus L plus d by dt of we can substitute the value here. So we will be getting minus summation I dou g by dou qi dot minus dou g by dou t. Now we can cancel these two terms. So we will be getting summation pi qi dot minus L minus dou g by dou t. This term is nothing but the Hamiltonian H. So we will be getting H minus dou g by dou t. So the new Hamiltonian H prime will be equal to the Hamiltonian H minus dou g by dou t. We will see the given option. Fourth option is an incorrect one because the Hamiltonian H prime is equal to H minus dou g by dou t. So only the option A and B are the correct one. Consider a point charge plus Q of mass m suspended by a massless inextensible string of length L in free space permittivity epsilon naught as shown in the figure. It is placed at a height d over an infinitely large grounded conducting plane. the gravitational potential energy is assumed to be 0 at the position of the conducting plane and is positive above the plane. If theta represents the angular position and p theta its corresponding canonical momentum, then the correct Hamiltonian of the system is. In this question, they have considered a point charge of mass m and the charge is positive. It has been hung in an inextensible string of length L. Below this charge, there is a conducting plate is also placed at a distance of d from the fixed support. They have asked us to find what is the correct Hamiltonian of this system. P theta is considered as the corresponds to the canonical momentum and theta corresponds to the angular position. Okay, so Hamiltonian is given by potential energy, kinetic energy plus the potential energy. Here potential energy is a addition of a two term. One is the potential energy due to gravity and also the potential energy due to the conducting plate. So the Hamiltonian will be T plus Vg, potential energy due to gravitation, and the potential energy due to the conducting plate. So first we will find what is the potential energy and the kinetic potential energy due to the gravitational force and the kinetic energy. Now if you look at the option, we can say that P theta square divided by 2m L square is a kinetic energy part. So it is based upon this option. We cannot eliminate it also because it is present in all the option. First I will tell you how to calculate the kinetic energy and the potential energy due to gravity. Now if you see this system, if we eliminate this conducting plate, it looks like a simple pendulum. Correct? For simple pendulum, the kinetic energy is given by half m v square, and v square can be written as half m L square theta dot square. And potential energy is equal to mg to this distance, right? So this distance can be obtained by d. This distance is L cos theta. So this distance must be d minus L cos theta. So it is d minus L cos theta. Okay, now here we have found the potential energy due to gravity is a positive term. Now if you look at the option A and option C, it is a negative term. So these two options are incorrect. Now we will see how to calculate the potential energy due to this conducting plate. Vc can be calculated by using a method of image concept. According to this concept, if we have a plus q charge here and at a distance of d minus L cos theta, we can consider another charge minus q at a same distance from the below the plate. Now we can calculate what is the work done in assembling the system without this conducting plate. That will be work done is equal to 1 by 4 pi epsilon naught q into minus q divided by 2 times of d minus L cos theta. But if we calculate the work done for a single charge and with a conducting plate, it will be half of this work done. So it will be work done is equal to 1 by 2, 1 by 4 pi epsilon naught minus q square divided by 2 times of d minus L cos theta. So that will be equal to 1 by 4 pi epsilon naught minus q square divided by 4 into d minus L cos theta. Right? So work done is equal to the potential energy of the system. So this is the potential energy Vc. Now if we see the option, it is a negative one. So answer is either B or C, right? Here it is given as 8 pi epsilon naught, but answer is 16 pi epsilon naught. So correct answer is option D. In the description box, you can find the solution for GATE 2018, 19 and 20 question paper. Please share and subscribe the channel.